look at the first question. You can mark your work. If you don't want to mark your own work, you can swap with your friends. Okay, next week we will do short quizzes. This week we will just go through each of the WA paper until you are conditioned to the type of question you should be expecting. Okay, this question. Okay, it says P and Q have this coordinate. I want to show that the gradient can be expressed in this form. So when you see this, you know you need to rationalize because there's no denominator. So gradient formula, gradient of PQ is y2 minus y1 over x2 minus x1. You can also do the reverse. Okay? So once I see this, you get your first method mark. You know the gradient formula. Second mark is where you rationalize. Okay? Please, when you multiply as a whole. So the bracket should be there. So when I see that you can rationalize, that's your second mark. Third mark, you are to simplify. So 2 root 6 times root 6 is 12. Or let's not skip some steps, is 2 bracket 6. Okay? 2 root 6 times root 12 is 2 root 12. Negative 3 root 2 times root 6 is negative 3 root 12. And the last one is negative 3 times 2. Okay, then of course, the denominator, it's a square minus b square. Since we have a plus b, a minus b. So let's square 6 and root 2. So if you can do this accurately, each of it, you get 1 mark. Final answer, 12 minus 6 is 6 minus root 12 over 4. Okay, but they want your answer to have root 3. So you have to split this into 2.
If they don't want it, maybe not do it.
If they put root 12, then no need. So if you simplify, you get 6 over 4, 2 over 4, root 3. Split it back into 2 fractions. So if the question asks for A, you have to tell me A is 3 over 2. And B is minus half. So your answer is 3 over 2 minus half root 3. Yes. Your answer should always be simplified.
So do we need to split the fraction or is it okay?
You need to split the fraction because they ask you to leave your answer of this form. Can. 1.5 minus 0.5 root 3. Can. Okay? So you must know how to rationalize and you should expect a question like that. How to create that fraction from the beginning? You can be given anything like volume, like area of triangle, or even gradient. So anything can be given. The context is up to the teacher, but the rationale is to get a fraction and you rationalize it.
Just can you ask like volume of a cube?
Can, anything can be tested.
Cone?
Okay, but you need to set up your own equation.
Can you ask volume of like a cone?
Why not? It's given in the first page. What?
No, it's not.
Oh, this one don't have. Oops. It's possible. Why not?
Yeah, please don't because I don't want to remember the formula.
Okay, next one.
And I don't remember.
Let's look at question 3. I repeat. Question 3 is not exactly tested for your WA2 because I will not use tangent. I will not use intersection at 2 distinct points. So I will not discuss discriminant here. Okay, but how to do? You need to sub equation 1 into equation 2. Remember your linear, non-linear. You need to form one equation first. So sub 1 into 2. So you will get so you get 2x squared plus 4kx plus 4k squared minus 3. This is the quadratic. So what did the question say? The question say the curve is a tangent to, no, the line is a tangent to the curve. So discriminant is equals to 0. So b square. So b square minus 4ac is equals to 0. So if you solve it, plus 24, you will get 24 equals to 16k squared. So k squared is 3 over 2. So k is plus minus square root 3 over 2. But the question say, leave your answer in exact form. When they say exact form means cert. Okay, but they say you need to rationalize your cert where possible. So if you look at this, you can actually split the answer as root 3 over root 2. So to rationalize cert means denominator cannot see cert. So times root 2 times root 2. So your final answer is plus minus root 6 divided by 2. So that's the solution. Okay? Okay, second part. Okay, ready or not? Okay, they say, what if the line meets the curve at two distinct points? So you know discriminant is greater than 0. Don't need to go and substitute again. What you know from here is that minus 16k squared plus 24 is greater than 0. So this is what you know. But when it's an inequality, remember you cannot solve like it's an equal sign. What you need to do here is you can do this. The solving is important, so pay attention to this part. This is what will be tested. I can give you an inequality and ask you to solve it from here directly. So I can start the equation from here and I say find the range of values of k minus of the story. Okay, so this is what can be tested. So from here, if you divide by 16 throughout, you will get k squared minus 3 over 2. Right? So how can you factorize? You can factorize if it's k squared minus root 6 over 2 squared. Why root 6 over 2? By right, it's the whole thing square root 3 over 2. But from part 1, you already know it's root 6 over 2. Okay, from part 1, you already know if I rationalize this, I will get this.
Shouldn't you do the 6 over 2 on the k? Like you sub the...
Yeah, here.
What is
Because why? This is the same as this.
No, but
right?
I can sub it to the k square.
No. It's a different set of k that I'm trying to find, so I cannot use this as k. Okay, why I do this is so that I can factorize this as a plus b, a minus b, which is what I need before I can solve quadratic inequality. So, I know that this one can be rationalized this way. Now, I can factorize it as k plus root 6 over 2, k minus root 6 over 2.
Okay, then which K are you solving for?
A new K. Okay, so now, this is a quadratic inequality. First thing is, after you factorize, you need to sketch out. So if you check, this is a minimum curve. Okay, the two coefficient is minus root 6 over 2 and root 6 over 2. Some of you will press the calculator, you get a minus 1.22 and 1.22, right? But we want the exact value, so it has to be insert. I want the part of the curve that is less than 0, means below. So this is the part that I want as my solution. So my K must be between. So this is the answer that I need to see. Huh? Yes, but if from here you give me the answer as this, but I didn't see the factorization, you cannot get the full mark. Okay? And at any point in time, I don't want to see this. From here, right? If those of you did this, then you tell me K is plus minus root 3 over 2. This is wrong. You cannot solve an inequality by taking square root.
Why must draw graph?
Because quadratic inequality, you have to figure out the shape of the graph. So I can give you a very simple one, like this. This is the most common mistake that you all will make for quadratic inequality. Like that, for example. Then a lot of you like to do this. Who say this is true? It's not an equal sign, so you cannot go and take square root here. So the step to take is factorize. So remember, whenever you have a quadratic inequality, you need to factorize this as K plus 2, K minus 2. So remember, the first step is always factorize your quadratic equation or expression.
Shouldn't you solve, right?
So once you factorize already, you sketch out. Because this is a minimum curve, coefficient is positive, and then you note down the root. Okay? I want the part of the curve that is above the x-axis. So my answer for K is less than 2, more than 2. So it's a split boundary. So remember, if it's a quadratic inequality, you cannot take square root over the inequality. It's nonsense. Okay? So be careful. These are very common mistakes.
So when you do separate fractions and when you do combine?
Depends on whether you want above or below the inequality.
That one is above.
This one is above. So I want this part. But this question, I want below. Less than 0. So that's why it's bounded.
What is a frowning curve?
If it's a frowning curve,
What is it above?
let's say I change this. Okay? Then when I factorize, this is a maximum curve. I want the part that is less than 0, that is here. But if I change this to more than 0, that is here. So there's 4 cases. If it's a Smalley curve, this is above 0. Okay? But if it's less than 0, I want a bounded answer. For maximum curve, if it's more than 0, it's above. Okay? This is less than 0.
But if it's more than 0, then you have to put it as a together fraction.
Yes, bounded.
That one is like
Then split.
there's like a in.
Then it's the till end answers. Okay? So this is the only part. Okay, then if you ask me, the explanation question is always the tougher one, where you need to go and understand what you are doing, and these are where you lose marks. And there must be questions like that to ask you to explain. So you should explain. You should see over the paper. There must be one little part there to ask you to explain. And this is the new syllabus. You need to explain your answer. So the last part says, Sean says that if I have y equals to x plus 3, it will intersect the curve. Is it true? So you look at the equation. Now he's very specific. He said the equation is x plus 3 instead of 2k. Sorry? This one? Okay, so here to here, I divide by 16. So I get k squared minus 3 over 2 less than 0. I want to apply a squared minus b squared. So I need to make sure this one has a square. The only way to do it is to square root and put a square. If I square a square root, it's the same thing, 3 over 2. Correct? If I square a square root, it is my 3 over 2. So I want to factorize this, right? This is my a square minus b square. So I just change to a plus b, a minus b. But why I don't want to use this? Because this is not the rationalized third. Part 1 already tell me this is not rationalized. So instead of writing this, I should use this. I don't need to square with the k because k is already squared. This is my original. I cannot do anything unless this has a square in it. And the only way to introduce the square is to square root, so that I don't change anything. Just like when I have k squared minus 4, I will change this to 2 squared, so that I can do my k plus 2, k minus 2. But now I'm given a number that I cannot square root, or I cannot change the form into something else. The only way I can do it is I square root this whole thing and I square. This is like I'm not changing anything because 3 over 2, if I square root is power half. If I square it again, it's like still 3 over 2. So I'm just introducing the square so that I can use my a plus b, a minus b. So this is when your quadratic inequality involves surds. For example, I change this one. Let me use a friendlier number. This one. What if I have k squared plus 2, no, minus 2 greater than 0? I want to factorize this, but I can't. Then I need to introduce surds. How?
Put a square for them.
Put a square root.
Then that test on a square.
Then I square. Because it's the same thing. Because what is square root 2 square?
2.
It's root 2 times root 2, right? Can you see it's still 2? I never change anything to it. I write it in this way so that I can have a square and I can factorize. So now I can factorize. Then I can do my sketching. And I want the part of the curve that is above 0.
So this term always must be this term.
Yes, you must have. It need not be. It can be your cross product rule also.
Meaning what?
This one. This is only when there's 2 terms, but there's 3 terms you can use this.
Like how can you show?
Like if I have x squared plus 3x plus 2 greater than 0, I factorize lah.
Oh yeah, same thing.
Yeah, same thing. Okay, so this is quadratic inequality. Okay, last one, this one. If you compare with your original equation, you should observe that k takes the value of 1.5. So now you need to check if your k is plus minus root 6 over 2, you will intersect at 1 point. So what is plus minus root 6 divided by 2? 1.22. Okay, so this one is k equals to plus minus 1.22. So for sure, once you check, you know that it cannot intersect at one point. Because intersect at one point means your answer must be 1.22. But your answer is 1.5. So it doesn't intersect at one point. Then you check. If I want it to intersect at 2 points, it must be between minus 1.22 to 1.22. Where is 1.5? Out of the range. So it doesn't intersect at 2 points, it doesn't intersect at 1 point, it doesn't intersect at all. So the claim is wrong.
So it doesn't intersect.
Yes. So how to write heaven? Okay, this one, quick one. Oh, that's all. Yes. My Chinese is okay. It's not. It's the A2. Okay, ready? Okay, remainder. What you can do to help yourself is let this be f of x. Okay? So by remainder theorem,
I find for the x first, then I go by the
find from the x first. No need to show that working. Don't go and equate this to 0 and show me the working. It's a rough work. It's not official working. Don't put it there.
What did you put it there?
It depends, but it's like not professional if you put it there. Yeah, no need to show that one. That one, this one equate to 0. Don't show as part of your working. Okay, you can write in pencil and erase off. Wait. You're already having break. What are you talking about? It's 4, right? No, negative 4, sorry. So you go and calculate, you should get 4. If you don't like this, you can do this.
Sure, but isn't that like prone to curve?
Up to you, which method you prefer. Different people like different things, right?
Sure, can show how to do using synthetic.
Wait Okay, wait
Cannot write.
This one cannot.
It's not plastic.
Sure, when
Then
can
you
you
can't
ever?
only one.
Sure, when are we allowed to use remainder and factor theorem when doing like
This is 4. So remainder is 4. So either you do long division.
Sure, but synthetic, right? All the x and y is only for coordinates, and all the x and y should be unknown except for y.
Okay, maybe I show you synthetic here. So 3 coefficient minus 1, x is 12, and the constant is 0, right? So you are dividing by 1/3. So first you bring down 3. So 3 times 1/3 is 1. When you add it up, is 0. 0 times 1/3 is 0. So 12 plus 0 is 12. 12 times 1/3 is 4. When you add up is 4. So your remainder is 4. Okay, so that's how you do synthetic if you like to use synthetic. Okay, this one.
So wait, what is synthetic? Not like synthetic.
When we want to solve cubic equation. So this one, I want to factorize, right? You can actually use your calculator to find a whole number answer. You will realize the answer is 1/3.
Sure, what if all 3 is a number?
Cannot be. So 1/3.
Sure, but
If it's 0.333, you know it's a fraction. Fraction, you can work backwards to get the root.
no, like sometimes when you press calculator, like in the big stack of events, right?
There should be one whole number or
But there was a
fraction.
question where there was like no number.
Must have one. If not, construction will have some issues.
Like one was I, then like the other two was like
Yeah. So, okay, this one has I, if you ask me. Okay, wait 1/3 plus minus 4, you will get 0 because it's a factor. So by trial and error, by factor theorem, you can conclude 3x minus 1 is a factor. So once you conclude this, you can go and do your long division. or your synthetic. So long division, if you do 3x minus 1, you will get x squared plus 4. Okay, so how do you conclude your answer? It is equals to 3x minus 1, x squared plus 4. This one. Can you factorize the quadratic further? Cannot. Because this is a non-factorizable quadratic. So, that's the answer for part 2 already. Okay, part 3. Partial fraction. One look at it. You must know that this partial fraction cannot be further simplified. It's a proper fraction already. Yes, strictly smaller. So write it like that. And then you can split it into 2. This is a linear. This is a irreducible quadratic. So you will split it as a over 3x minus 1, bx plus c. Multiply throughout by 3x minus 1, x squared plus 4. You will get 11x squared plus 9x plus 4, x squared plus 4. This thing, remember to bracket. Very important. I will mark you wrong. This bracket must be there. If you miss out the bracket, it's a different expression, it's a different answer. Yeah. This one? You can, because you can. It's faster. You can take from the top. Can. Okay? So now, I want to solve for my unknown, right? You can mix and match what you want. You can, in fact, sub x as 1/3. Okay? And this one will disappear. So you will get 4 and 1, 9. Yeah, go. Okay, go. So after you solve, A, you should get what? 2. Okay. So once you solve for A, next one, you can compare coefficient of x squared. So x squared is 11 on the left hand side. On the right hand side is A plus 3B. Okay. So since I know A is 2, B is 3. Okay, and then of course the last one, you can compare constant term. So the constant term is 4. And we have 4A plus minus C. So again, A is 2.
So I'm going to ask like partial fraction.
Yeah, possible. So it's either I ask you one that needs to do long division, one that don't need.
So one that needs to do long division, 7 marks.
It will be more marks. But if it doesn't require 5 marks.
So if my long division is wrong, do you have to see it?
Yeah, we'll have. So the final answer,
Is there anything to check?
you expand out and double check. From here, this
Like
step.
past method.
Yeah, you expand out.
What's the use of it?
Like you cross multiply from here. Okay, this is the answer. You can sub in one value 1, see whether it's valid or not. Okay, so this is the final answer. Remember to sub it in. Okay, the last question is supposed to be the slightly tougher one. In what?
Alexander.
The hard one is I ask you all to come up with your own equations, solve your own unknown. The easy one is I give you all the unknowns, you just solve the unknown. That's the difference. So this one, they say this is the expression. If you want, you can let f of x be this expression first.
Isn't that practically somewhat like this similar?
This one no need.
Complete the square.
Yeah, complete the square. Okay, so here, they say remainder when you divide by this.
Can you ask a question like this?
Why not?
Why not?
Yeah, it is. By remainder theorem, I will sub in -1 and I get my remainder. So I plug in -1 into the equation. I will get k squared minus k minus 3k plus 5 plus 2. So my remainder is k squared minus 4k plus 7. Okay, here's the highlight. I want to show that the remainder is at least 3. So I need to do my completing the square here. So I will plus bracket square minus bracket square. This is important for E-math curve sketching. So I will always divide by 2. The number I put in here will be -4. So the first 3 terms is my k minus 2 square. These 2. This will give me -4 plus 7. So what do I get? I get k minus 2 square plus 3. So what do I know? K minus 2 bracket square is greater or equals to 0 for all real values of k. So if I plus 3 on both sides, it will be greater or equals to 3. So what is this? This is my remainder. So shown. I want to show that my remainder is always at least 3. This is at least 3. Okay? So showing questions are always slightly more challenging, but if you know completing the square, then no problem. Okay, Ken? The first time I sit for WA class test for A math.
F9.
Single
So
digit.
didn't you say you got like A1 for like
For my first class test.
Like
Then after that don't have already.
so like
Okay, so you can see, since is greater than √6/2, there will be no solution. Okay, so I hope you can understand what I'm saying. This type of question is the explanation type. It will usually not be more than 3 marks, 1 or 2 marks, just to see whether you have a higher understanding or better understanding of the concept. Okay? Okay, let's look at the question 4. Okay, you will see that question 4 is a bit similar to 2020 paper. In fact, the numbers are similar.
For the email people will be harder.
Fair one. Every paper has its own interesting point.
So, but will this type of question be tested?
Or E-maths
Yeah.
I don't know, I haven't seen the E-maths paper. Anything can be...
is he even making it this time?
I will ask.
Wait, Chef, can you give us the hard version of the now?
So I like
Okay, I hope that after you do the WA2 paper, you have a general idea.
I'm gonna
Okay? All these are conditioning. is to get you used to the exam questions, exam setting. Okay, ready or not? Almost. So you must not only explain, you must tell me the conclusion, correct or wrong. Some of you explain fantastic, but no stand. So you need to explain your stand as well.
Give us the hard question.
Of what? The textbook question.
No, your paper.
The hard version. Cannot. The questions are still similar. I simplify. How can I give you? I give you is like giving.
So how were you not lethargic as a student, man? Like I feel like I want to die. I like tired.
Because you all at night don't want to sleep.
It's called rushing English WA. The interview is today.
When you were studying, were you like good?
Well, I what?
Were you good in math when you were studying?
I like math though. Good is very subjective. Okay, fast on. The paper.
Should I give her a 5 best score?